So this is a unit circle. Y'all have all practiced filling in the little points of intersection. All the over 6 have that same point of intersection, except when you go from quadrant to quadrant, the SIGN sign changes on the coordinates. All of the 45-degree ones, the ones that have 45-degree reference angle, which are also the over 4 ones, have square root of 2 over 2, comma, square root of 2 over 2, and so forth. With inverse sine and with the inverse trig functions, we're either going to be looking from 0 to pi, or from negative pi over 2 to pi over 2. So down here, for the inverse trig functions, we're not going to be looking at, saying 330 degrees or 315 degrees. Do you remember how the negative angle measures work? You start at the positive x-axis and you move clockwise. So this 330 degrees is negative 30 degrees. I'm writing the negative angle measures for each of these. The 315 degrees is negative 45 degrees. 300, negative 60 degrees. It's just these angle measurements. Like 3 pi over 2, I'd write negative 90 degrees. And the radian measures are the same as what's up here, except they're negative. Negative pi over 6, negative pi over 4, negative pi over 3, negative pi over 2. Now, let's evaluate some of these trig function or inverse function. I'm just going to make up a few. Keep in mind, if it's inverse sine or inverse tangent, your answers are going to be angle measures between negative 90 degrees and positive 90 degrees, or in other words, negative pi over 2 and positive pi over 2. If it's inverse cosine or inverse cotangent, it's going to have answers between 0 and pi. For instance, let me find a blank sheet of paper. Right here. Here it goes. Let's find inverse sine 1/2. Then we'll find inverse cosine 1/2. Then we're going to find inverse sine negative 1/2 and inverse cosine negative 1/2. There's not going to be a whole lot of work to this. So first thing we're doing, inverse sine 1/2. We're going to look at the little unit circle. Inverse sine 1/2. Inverse sine 1/2. Inverse sine 1/2, you're looking between negative pi over 2 and pi over 2. You're looking at the y coordinates. What's the angle value between negative 90 degrees and positive 90 degrees that has a sine value of 1/2? What's the angle value? 30 degrees? At 30 degrees, the sine is 1/2. Or pi over 6. I'm going to write both, 30 degrees or pi over 6 in your homework, and I'll log on and we'll look at the My Math Lab in a moment. But in the homework, there'll be some that'll say give it in degrees, others write your answer in radian. So I'll do both of them. Now what about inverse cosine 1/2? For inverse cosine, you're looking between 0, and pi. So you're going to go through and figure out at what angle measurement is cosine equal to 1/2. Where's cosine of half? Like you're looking only between 0 and pi. So it would be it's just 60 degrees, or pi over 3. For inverse cosine and inverse cotangent, you're looking from 0 to pi. For inverse sine and inverse tangent, that's the ones that you're looking from -90 to +90. Okay. For the next one, here's my thought process. Inverse sine -1/2. Since it's inverse sine, which part am I going to cover up? Am I going to cover up the bottom part or this part, the left-hand side? Okay, the left. We're looking only from -90 to +90. So these are the signs of the y values. So where do we have a y value of -1/2? -30 degrees or -pi over 6. Do not write 330 degrees and 11 pi over 6. -30 degrees or -pi over 6. For inverse cosine, which part? Inverse cosine -1/2. Am I going to look at this right-hand side here, or do I cover up the bottom and look just at the left-hand side?
Is it that one?
Excuse me, or do I cover up the bottom?
That one?
Yeah. Inverse cosine is going 0 to pi. So let's see. Looking through here, cosine's the x-coordinates. So I'm just sort of scanning through here. Where's the next value of -1/2? At 120 degrees or 2 pi over 3? Ooh, I'm getting sort of low there. Now see the way that I'm doing the inverse sine version. If they're both positive, the numbers in the parentheses are both positive, you just look in the first quadrant. It's when that number in the parentheses is negative. If it's inverse sine or tangent, you look down here. If it's inverse cosine or cotangent, you look over here. And if you're thinking, well, wait a minute, what about inverse secant or cosecant? For those, we're just going to rewrite in terms of inverse sine and cosine. Let me show you what I mean by that. How do we evaluate inverse cosecant or inverse secant? If we had something like this, that's fine. Hey, I'm going to use arc. My habit is to use the little -1 for inverse, but I'll try to force myself to use. Let's say we had arc secant -1/2. If you have arc secant or arc cosecant, I think it's easiest just to rewrite it in terms of its inverse. It's reciprocal. The reciprocal of secant is cosine. So the reciprocal of secant is cosine. The reciprocal of -1/2 is, say it again, -2. Oh, wow. Is there a -2 on this unit circle? No, this is not defined. When we're doing the homework, there'll usually be an option, a little button that you can click, is not defined. Okay? Now, what did I mean to do right? I didn't mean for that one to be undefined. What I was meant to write was this. Arc secant -2 would be arc cosine what? -1/2. And have we done that one? Well, even though we have, I'll do it as if we haven't already done it. Inverse cosine is 0 to pi. So looking through here, where is cosine negative 1/2? The 120 or 2 pi over 3? Arc cosecant 2 over the square root of 3. Arc cosecant 2 over the square root of 3. How would I do this? Well, let's rewrite it in terms of its reciprocal. What's the reciprocal of cosecant? Sine. And now flip the number. Square root of 3 over 2. So this is a positive number. Well, it's sine, so we're looking here. But since the number's positive, it's not going to be down here. Okay? So did I hear 60 degrees? Yep, and that's right. The sine of 60 degrees is square root of 3 over 2. Oops. Put up right. 3 pi is 2 pi over 3. Sorry. Okay? Now, I know I printed out the homework, so if you let me ruffle around through all this crap I carry with me in this embarrassing box, evidently my brother's students told him that the box did look sort of embarrassing, lugging around the box. If not, I'll just pull up my math lab and we'll do some of these online. Well, let's do a few more just for the video with arc tangent and arc cotangent, as those can be a little bit messier. Here's all the stuff we did the last time. Now I want y'all to start thinking about arc tangent -1 and arc cotangent -1. Oh, I'm really getting into the hang of using this arc instead of the little -1. Oh. It's getting better. I found the unit circle I printed out to bring. Still haven't found. Okay, could y'all talk your way through the finding arc tangent -1? Let's see. Arc tangent. What part of the unit circle am I going to cover up? The bottom or the left? The left? Okay. So we're looking at arc tangent -1. That's going to be between -90 and +90 degrees. So going through here, sine over cosine, where would you get a -1? If you go like -1 over 0, not -90 degrees, that'd be undefined. If you're going sine over cosine, sine over cosine, -45, at -45 degrees, if you went sine over cosine, would all of that cancel? Negative square root of 2 over 2 over positive square root of 2 over 2, I think that would cancel down to just a -1. So your answer would be either -45 degrees or -pi over 4, depending on whether you're told to do it in radians or degrees. Now, how does that differ from arc cotangent -1? Arc cotangent -1, you're looking from 0 to pi. where would it be? Did y'all hear Jerry? 135 degrees. At 135 degrees, or 3 pi over 4, that was where we would have, you go sine over cosine, you'd get a -1. No, give me, I'm going to take a break.